This video is on section 1.7, linear and absolute value inequalities. So first we're going to look at inequalities and how to write those same answers in interval notation. So here we would say that these are solutions for some x value which cannot equal 3, that's why this circle is open. And then any value that's greater than 3, so 3.5, 4, 4.1, 4 and 7/8, anything like that, all the way to a right arrow, which is going to be positive infinity. So we would say this is all x values that are greater than 3. And in interval notation, you would say this is from 3 to positive infinity. This would represent all values for some unknown x that are less than 4. They could equal 4, that's why the 4 is filled in, and then all of these decimals here. So 0.5, 1.238, pi 3.14, that would work. So x values that are greater than or equal to 4. And in interval notation, we would say starting with 4, not starting with 4. All the numbers less than 4 means that we're ending with 4. And then everything less than that would be a left arrow or negative infinity. So from negative infinity up to 4. And here's kind of a summary of the ways that you might write set notation, interval notation, and then if you should have the interval be open, which means you're not including the number, or closed, which means that you do include the number. All right, so we're going to solve some linear inequalities. Recall that when you multiply or divide, by a negative, you should flip the inequality symbol to make the expression true. So for example, if I was considering two negative numbers, -6 and -2, I would say -6 is less than -2. That's a true statement. Numbers that are further to the left on the number line are smaller than numbers that are further to the right. So -6 is less than -2. But if I went through and I divided this by -1, so that I was comparing +6 and +2, it would no longer be a true statement for me to keep that symbol facing the same direction. It is not true that 6 is less than 2. That's not a true statement. +6, +2, at this point, once I divided by that -1, I have to flip that symbol around and say 6 is greater than 2. So make sure if you're working with a linear inequality that anytime you divide by a negative on both sides, or if we were to multiply by a negative to get rid of it, that we do flip that symbol to keep it a true statement. Okay, so here we're going to solve each of the following. We're also going to write our solutions in interval notation, and then we're going to graph a number line just to say what those values are in a number line. So first here, to get the x alone, I would subtract 2 from each side, and I'd be left with -5 is less than or equal to 5. Notice this wasn't a problem that I subtracted a 2. It's not that all negatives flip the sign. It's just specifically when you multiply or divide by a negative. So next, to get the x alone, I'm going to divide by a -5, and that's going to make me flip my inequality symbol. So I have x is greater than or equal to -1. To write that in the interval notation, I'm going to say that -1 is the smallest number, and then we're going to go to all the numbers that are greater than that. So from -1 to infinity, this is equal to, so I'm going to include -1, and then go all the way to infinity. I don't say that I include infinity because I can't actually get to infinity on a number line to say, hey, there's the number right there. So if I was to draw this answer out, you can put as many numbers on your number line as you want, just put a few. I'm going to circle -1 and fill it in. then show that all the numbers are getting bigger. You could also put a bracket here if you wanted. Both of those are fine for me if I was grading this. Okay, for the next problem, we have some fractions. I don't want to deal with the fractions. And so I'm going to look at what a common denominator between 2 and 4 would be. And that common denominator would be 4. So I'm going to take this entire inequality and multiply every term by 4. So 4 times 1/2 x is 2x. 4 times 3 is 12. 4 times 1/4 is just 1, so just 1x. And then 4 times 2 is 8. So since I was multiplying by a positive, I don't have to worry about flipping my symbol. And now I can go ahead and get the x's to one side and get the numbers to the other side. X is greater than or equal to 20. So 20 is the smallest number, and then it's all the numbers that are larger than 20. And I'm putting a bracket because I can include 20. And your number line doesn't have to include 0, in my opinion anyway. So I'm going to say I'm going to equal 20, and then I'm going to have all the values that are greater than 20. Okay. Next, we're going to look at compound inequalities. These are inequalities where you have a combination of two inequalities, either using the word and, which means that both solutions you find have to be true at the same time, or using the word or, where it could be one solution type or the other. So these are where you're going to see either the word and, or it's going to look kind of like a sandwich. You've got some algebraic expression in the middle is sandwiched in between two numbers. Here's where you have or. Typically those solutions are going to be going the opposite directions. So sometimes they can manipulate the way that they're written so that it forces one to become the other, and we'll see what that looks like. All right, so here's some examples. First, we have an or problem. So I'm just going to go ahead and solve this as two separate inequalities. So first, I've got 4 minus 3x is less than negative 2. I'll start off by subtracting the 4 to the other side. And then I can divide by negative 3. And since I divided by a negative, I'm going to flip the symbol. So the first solution I have is x is greater than 2. And then for the other one, I'll go ahead and distribute the 3 before I write this down. So 3x minus 6 less than or equal to negative 6. I'll go ahead and add the 6 over to the other side. And then I'll divide by 3. So x is greater than 2 or x is less than or equal to 0. So x is greater than 2 or x is less than or equal to 0. So this is pretty typical for an or problem. Your solutions go in opposite directions. So for this first one, we're going to say the interval notation would be from negative infinity to 0, including 0. And then for the second one, we'll say from 2 to positive infinity, 2 to positive infinity, not including 2. And anytime you have two answers, one answer or the other answer, we would put a U in between them. This one, union, that one, it just means that I need both answers to be considered right. I can't have one or the other. I have to have both answers written down at the same time. That doesn't mean that your x value is going to be both of them at the same time. It means that you could plug in an x from either one of them. But both answers must be present to be correct. All right, this next one, you can see it looks like a sandwich problem. We have our unknown expression is sandwiched in between two values. So here I'm going to add the 1 to start getting the x alone, and I'm just going to do that on all of the, I don't have a left side and a right side, but I do have a middle left side and right side, so I'm going to do this to the middle, left, and right. So negative 3 less than or equal to 3x less than 6. And then I'll divide by 3 by all three sides. So x is sandwiched in between negative 1 and 6 divided by 3 is 2. So there's negative 1, there's 2, and our x value would be in between those values. So negative 1 to 2, somewhere in between those. You can equal negative 1, you cannot equal 2. This problem has an and, so we'll have to do some work to see which answer it's going to end up looking like. So I'm going to do the two inequalities separately. So first I'll add 3 to the other side. 2x is greater than 8. Then I'll divide by 2. So x is greater than 4 is my first solution. Then I'll do the other one. I'll subtract 4 to the other side. Now I need to divide both sides by negative 1. X is greater than or equal to positive 1. Now, to know which of these it is, we have to think of whether the two expressions have to be true at the same time, whether they are going in opposite directions. We have to think about how that works. So this one was, you had two separate options that did not overlap. You said x was less than 0, less than or equal to 0, or it was over here, x is greater than 2. Those were not true at the same time. This one, you could think of them as two separate things and look at the overlap. So the numbers that were greater than or equal to negative 1, so here's all the numbers greater than or equal to 1, and the arrow would have gone this way. Numbers less than 2, those went that way, and we were kind of looking at the overlap between those two inequalities. If they were going opposite directions, then they overlapped in the middle, and the middle created that sandwich. So here, we don't have a sandwich being created, but we do have some overlap. So if we do 0, 1, 2, 3, 4, 5, if we look at the numbers that are greater than or equal to 1, that's all of those. If we look at the numbers that are greater than 4, that's all of these. So if we want to have things that are true at the same time, because the word in between these is and, they both have to be true at the same time. It can't be like this, one or the other. They have to be true at the same time. So we're going to look at the overlap. So this is the portion of our answer that is true. So here from 1 to 4 is nice, but it only works for 1. We've got to look at what works for both inequalities at the same time. So we're going to say x is greater than 4 is our final answer, 4 to infinity. And we'd have to kind of erase this piece right here because it is not part of the overlap like this piece is. Okay, let's do this last one. So I've got an and, that's another situation where I'm going to have to look at the answer before I make a determination on which one it looks like. So I've got a fraction, I want to get rid of the fraction, I'm just going to multiply by 3. So negative 2, this is times 3 divided by 3, so I guess the 3's would cancel out. So negative 2x, and then 3 times 4 is 12. And then I can divide by negative 2. X is greater than negative 6. Okay, over here, we can multiply by 4. So divide by 4 and times 4, those would cancel out, and we would just have 3x. 4 times negative 6 is negative 24. Then we can divide by 3. X is less than negative 8. Okay, so we have an and, which means we have to look at what's true at the same time. So we're going to be looking for places where we have some overlap. So answers that are greater than negative 6, answers that are less than negative 8, and we're looking for overlap, but there isn't any. So if this inequality said the word or in between, then we would be good. This would be the answer. But this inequality doesn't say the word or in between. It says the word and in between. We would need to have some overlap to have an answer, and we don't. So the answer here is no solution. It is impossible for these two inequalities to be true at the same time. So there's no solution. I can't write that in interval notation. There's just no solution. Okay, let's move on to the next type of problem. So next we're going to look at how to solve absolute value inequalities. And absolute value inequalities are actually compound inequalities. They just don't look like it yet. So first thing I want you to remember is that the absolute value of a number describes how far away that number is from 0. So here they said x is less than 3 units from 0. So we would say if x is some unknown number, it would be less than 3 units away from 0. Here, this is saying that x is greater than 5 units away from 0. X is greater than 5 units away from 0. So if you have an absolute value problem and your symbol goes this way, it's a less than problem. It makes a sandwich with the answers. If you have this type of symbol, it's a greater problem. It's greater than, and the answers go one direction or the other. Okay, so let's go ahead and try the first example. It says the absolute value of 3x plus 2 is less than 7. So this looks like this right here, which means that 3x plus 2, our unknown, is going to be sandwiched in between 7 and negative 7. 3x plus 2 is going to be sandwiched in between negative 7 and positive 7. And then we can go ahead and just solve the compound inequality. So I'm going to subtract 2 from all of the sides. 3x is in between negative 9, positive 5. I'll divide by 3. And x is in between negative 3 and 5/3. So we would say that our unknown value is just in between 3 and 5/3. There's our interval notation. Cannot equal 3, cannot equal 5/3, but it's somewhere in between them. And if we were to draw this on a number line, there's negative 3. 5/3 is 1 2/3. So it would be a number somewhere in between here. So this is less than, which created a sandwich answer. Okay, this one isn't ready yet to be able to see which one it is because of the negative 2 in front of the absolute value sign. So you can't determine which one it is until all you have is your absolute value sign on one side and a number on the other. Right now we have an absolute value sign with a coefficient. So I'm going to divide both sides by negative 2. to get rid of that coefficient. I have 4 minus x in the absolute value sign. I divided by a negative, so I'm going to flip my symbol around. Negative 4 divided by negative 2 is positive 2. And then when I look at this symbol, this is a greater problem. Greater. So it's going to be my unknown number, and I'm going to have an or. My unknown is going to be less than negative 2 or greater than positive 2. My unknown is less than or equal to negative 2, or my unknown is greater than or equal to positive 2. So negative 2, positive 2, going opposite directions. And then I'll go ahead and solve. So I'm going to subtract 4. Negative x is less than or equal to negative 6. Divide by negative 1. X is greater than or equal to positive 6. I'll do the same thing over here. Divide by, not negative x, divide by negative 1. X is less than or equal to 2. So we can equal 2, it can equal 6. This is an or, okay. X is less than or equal to 2. X is greater than or equal to 6. And this is exactly what we want from an or problem. They should be going opposite directions. And I'm going to write my interval notation. I'm going to say my first interval is from negative infinity to 2, including 2. U for my second answer, starting with 6, going to infinity, and a bracket around the 6. All right, for this example, we have the absolute value sign is all alone. The number on the other side is all alone, so this would be ready for us to determine if it's a less than problem or a greater problem, and we can see that the symbol is greater, but when we see the number, we have to stop. And the reason we have to stop is because this is a negative number. This is talking about a negative distance. It just makes the problem weird. So if we had, like the last two problems, we said the distance from some unknown number to 0 is a distance of less than 7. The distance of some unknown number to 0 is a distance of greater than 2. That kind of made sense. Here, we're trying to say the distance of some unknown number to 0 is negative 3, and that doesn't really make sense anymore. So we're going to think of this instead knowing that absolute values always are positive. Distances are always positive. So I'm not going to do it like this, because this is a negative value. And negative values are kind of the exception to the rule. So if this right here had said less than, we would say there's no solution to the problem. It's not even possible for something that is supposed to be positive to be less than a negative. You'd say no solution. But here we have an absolute value, which is always going to be positive, is greater than or equal to negative 3. So an expression that is always positive is greater than or equal to a number that's negative. Well, that's going to be true no matter what you plug in for x. So we're going to say always true no matter what you plug in for x. And if that is the case, then all real numbers are true. all answers are true. So negative infinity to infinity, all answers would work. And if we want to graph this, we'd say -1, 0, 1, and we would just make the whole number line. We'd make the whole number line dark. Anything that you want to plug in is going to work. So this one's kind of an exception. You have to stop using the rule, stop using the process, and think it through. Okay, one more problem. So I'm going to add the 3 over to the other side. I can't determine which one it is yet because I need to make it so the absolute value is alone on the one side. Could be the left, could be the right. And so that the plain number is alone on the other side. Then I can make a determination. So here's my absolute value. It's alone. The number is alone. Now I can determine what this is. This is a less than problem. And we know that less than problems make a sandwich. So x minus 6 is sandwiched in between +1 and -1. And then we can go ahead and solve it. So we have 5 and 7. X is in between 5 and 7. So there's our interval answer. And there's our number line answer. All the numbers between 5 and 7 would be true. Okay, let's try a couple of application problems that could use inequalities. Compound inequalities could use absolute value, that sort of thing. So, first problem says Remington scored 74 on his midterm exam in history. If he is to get a B, the average of his midterm and final must be between 80 and 89 inclusive. So it could be 80, it could be 89, but it has to be between those. In what range must his final exam score lie for him to get a B in the course? Both exams have a maximum of 100. Both exams have a maximum of 100 points possible. Okay, so the way that we determine Remington scores, they're saying his midterm and then his final are the only two scores that are going to count. So we're going to say his midterm plus his final. If you divide that by 2, that's how you find the average score. So we want his average score between his midterm and his final to be in between two grades, to be in between 80 and 89, sandwiched between those. So I'm writing a compound inequality because I have two options, and I'm writing it as a sandwich because it's going to be between those two options. And now I'm going to go ahead and solve. So this is divided by 2, so I'm going to go ahead and multiply by 2 times 2 times 2. So that canceled. 160, 74 plus x, 89 times 2, 178. And then I'll subtract 74. So x is going to be in between, what is that, 86? So mathematically, we know that his final exam score would have to be between 86% and 104%. 104% is probably not possible. So I'm going to say that we're probably going to max out at 100%. So his scores are going to have to be between 86 and 100% if he wants to have an average that allows him to get a B. Since 104 is not a value we can get, he probably can't get an 89. He can't get the higher end of the average that he wants, but he can get a B average. All right, next, a technician is testing a scale with a 50-pound block of steel. The scale passes this test if the relative error when weighing this block is less than 0.1%. If x is the reading on the scale, then for what values of x does the scale pass the test? So the absolute value of x minus 50 is going to be the absolute error. This tells you the difference between the steel that is being tested, if the scale, it's a scale. If the scale that's being tested is above 50 or below 50, it's just going to tell you the difference between the scale and the 50 pounds that it should be. That's the absolute error. How far off is that weight? The relative error says what percentage of that weight is above the 50 pounds or below. What percentage error does it have in relation to the 50 pounds? So if we do x minus 50, how far off is it, divided by 50, then we're doing the relative error and we're saying what percentage is it out of 50. So what we want is we want this relative error to be less than 0.1%. And let me write this off to the side because 0.1% we can't do a computation with. 0.1%, for you to use a percentage as a number, we have to take the decimal and move it 2 places to the left. 1, 2. So this would be 0.001. So 0.1% is the same as 0.001. So 0.001. Okay, so we want the relative error to be less than 0.001. So I'm going to go ahead and start getting the absolute value sign alone. So I'm going to multiply by 50 on each side. .05. And this is a less than sign, so it's going to make a sandwich. So we're going to say x minus 50 is between positive 0.05 and negative 0.05. And then to get x alone, we're just going to add 50. So the weight of the scale should be between 50.05 and 49.95 pounds. And if it's in between those, then it will pass the test for weighing less than 0.1% off of the numbers that it should. So 49.95 to 50.05. It will be very close to weighing what it should if it is between those weights.